We'll start in 1 minute. In a few minutes, we'll start section 9.2 on how to solve quadratic equations by completing the square. But first, we'll look at 3 more problems from section 9.1. I didn't send these problems, so you can do these on extra paper. So this equation is all ready to apply the square root property. We have the binomial x plus 4/3 squared equals -3. So we apply the square root property and we write x plus 4/3 equals positive and negative square root of -3. And then all we have to do is subtract 4/3 from both sides. We can write it as x equals -4/3 plus and minus the square root of 3 times I. So here we remember that the square root of a negative is equal to the square root of a positive number multiplied by I. And we're using the definition of the imaginary unit. The square root of -1 is equal to I. Okay, the next problem. There are 2 ways that we can go about solving this equation. Well, there's more than 2 ways, but 2 ways that we know of. Notice that the left-hand side is a perfect square trinomial. So if we factor the left-hand side, we get 2y minus 3 quantity squared equals 9. And then we can apply the square root property. And we write 2y minus 3 equals positive and negative square root of 9. So in the next step, we'll add 3 to both sides and also simplify the square root of 9. So we get 2y equals 3 plus and minus 3. And then divide everything by 2. We get y equals 3 plus and minus 3 all divided by 2. We do want to simplify further because we can evaluate 3 minus 3 and 3 plus 3. So we will write the solutions separately. One is y equals 3 minus 3 divided by 2, or y equals 0 divided by 2, which means y equals 0 is one of the solutions. And then the other solution, y equals 3 plus 3 divided by 2, 6 divided by 2 is 3. Okay, so the 2 solutions are y equals 0 and y equals 3. The alternative way to solve this equation, or an alternative, subtract 9 from both sides, and then we get 4y to the second minus 12y equals 0. and then solve by factoring. Solving by factoring is something we learned how to do earlier this semester. Factor the greatest common factor out, which is 4y, and the other factor is y minus 3. Then set each factor equal to 0, 4y equals 0, and y minus 3 is 0. If 4y is 0, divide both sides by 4. 0 divided by 4 is 0. And then for the other one, add 3 to both sides, we get y equals 3. So either way, we get the same solutions, as we should. In the next example, w to the second plus 10w plus 25 equals negative 32. The left-hand side is a perfect square trinomial, so write it in factored form. W plus 5 squared equals negative 32. And then apply the square root property. And we get w plus 5 equals positive and negative square root of negative 32. And then subtract 5 from both sides. We get w equals negative 5 plus and minus the square root of 32 times the square root of negative 1. We will replace the square root of negative 1 with I, and we can also simplify the square root of 32. So the square root of 32 is the square root of 16 times 2. 16 is the largest perfect square factor of 32, and then this becomes 4 times the square root of 2. So the two solutions then are w equals negative 5 plus and minus 4 times the square root of 2 times I. Those are the two solutions. Okay, that's a quick review of section 9.1 problems. We'll move on to section 9.2. Section 9.2 is solve quadratic equations by completing the square. So this is going to be pretty closely related to section 9.1, where we solved by applying the square root property. So here's a description of the completing the square method. Solving a quadratic equation by completing the square involves some preliminary work. Once that work is complete, the resulting equation can be solved by using the square root property, which is what section 9.1 is about. The expression completing the square in this context simply means to create a perfect square trinomial. You have seen me do that before. I did it yesterday. We created a perfect square trinomial in one of our examples. Okay, so another piece of information that is useful to remember, and I say this repeatedly this semester, recall that a perfect square trinomial is the result of squaring a binomial. So here are a couple of examples. If we square the binomial x minus 3, remember what that means to square a binomial. It means to multiply the binomial by itself. So x minus 3 times x minus 3, we have x squared minus 3x minus 3x a second time, and then negative 3 times negative 3, we write plus 9. And then when we combine like terms, we get x squared minus 6x plus 9. This is a perfect square trinomial. It's the result of squaring a binomial. Okay, a second example. This time we're squaring the binomial 4y plus 5. But that means 4y plus 5 times 4y plus 5. 4y times 4y is 16y to the second. And then plus 4y times 5 is plus 20y. And then plus 5 times 4y is plus 20y a second time. And then 5 times 5 is 25. Combine like terms, we get 16y to the second plus 14y plus 25. So this is also a perfect square trinomial. It's the result of squaring a binomial. Hey, since a perfect square trinomial has characteristics that are known under appropriate conditions, a perfect square trinomial can be constructed. Okay, so the following example illustrates what to do when completing the square. So remember what completing the square means? It means we're going to create perfect square trinomials when we complete the square. Okay, so in this example, we begin with x squared plus 6x. In number 1, observe that the coefficient of x squared is 1. Then we compute 1/2 of the coefficient of x. The coefficient of x is 6. So we compute 1/2 times 6, which is 3. In step 3, we square the number that we found in step 2. So in step 2, 1/2 of 6 is 3. So in step 3, we square that number. 3 squared equals 9. And then in step 4, we add the number that we found in step 3 to x squared plus 6x. So in this case, it means add 9 to x squared plus 6x, so x squared plus 6x plus 9. X squared plus 6x plus 9 is a perfect square trinomial. Because x squared plus 6x plus 9 is equal to the binomial x plus 3 squared. Okay, when solving quadratic equations by completing the square, these are the steps that you'll go through. First, we will practice creating perfect square trinomials by completing the square. So on the next page, the directions: create perfect square trinomials by completing the square. So we're beginning with x squared plus 2x. Notice that the coefficient of x squared is 1. The next step, we take 1/2 of the coefficient of x. So 1/2 times 2 is 1. Then we square that number. 1 squared equals 1. And then if we add 1 to x squared plus 2x, we have a perfect square trinomial. When we write x squared plus 2x plus 1 in factored form, we get the binomial x plus 1 squared. That's what it means for a trinomial to be a perfect square trinomial. If you factor it, it's equal to a binomial squared. Okay, the next example. To create a perfect square trinomial out of this, first note the coefficient of x squared is 1. So make sure you absorb that. The coefficient of x squared is 1. Okay, then we take 1/2 of the coefficient of x. This time the coefficient of x is -2, so we take 1/2 of -2, which is -1. In the next step, we square this number -1. So -1 squared is +1. And then if we add 1 to x squared minus 2x, we now have a perfect square trinomial. So x squared minus 2x plus 1, we created a perfect square trinomial. When we write it in factored form, this one will be the binomial x minus 1 squared. So when creating perfect square trinomials of this sort, it's the same process. Okay, so the next example, x squared plus 7x. The coefficient of x squared is 1. Then we take 1/2 of the coefficient of x. The coefficient of x here is 7. So 1/2 times 7 is 7/2. In the next step, we square 7/2. When we square 7/2, that means 7/2 times 7/2, which is 49/4. And then when we add 49/4 to x squared plus 7x, we have another perfect square trinomial. So this one is x squared plus 7x plus 49/4. This is a perfect square trinomial. It's equal to a binomial squared. So how do we know what binomial it is? Well, we know that it has to have x because of the x squared. In the trinomial, we have 2 plus signs, so the binomial has to have a plus sign. So x plus some number. How do we know what number? This number is the same number we got when we took 1/2 of 7. So x plus 7/2 quantity squared is equal to the perfect square trinomial. You can always verify it by multiplying x plus 7/2 times x plus 7/2. Okay, on the next one, we're beginning with x squared minus 13x. Notice the coefficient of x squared is 1. Okay, since the coefficient of x squared is 1, the next step is to take 1/2 of the coefficient of x. The coefficient of x is -13. So 1/2 of negative 13 is negative 13 halves. In the next step, we square that number, negative 13 halves. So the number negative 13 halves, that means negative 13 halves times negative 13 halves, which is positive 169 fourths. Then when we create a perfect square trinomial, we do so in this case by adding 169 over 4. So x squared minus 13x plus 169 over 4. Since we created a perfect square trinomial, it's equal to a binomial squared. So what binomial is it that we squared? Since the trinomial has x squared, 1x squared, the binomial has to have x. Since the trinomial has minus and then plus, the binomial has to have minus. Or in this step, you could just say, well, what follows x? The number that follows x is what I got when I took 1/2 of negative 13, so negative 13 halves. So in the binomial, it's x minus 13 halves. And when we square the binomial, we get the perfect square trinomial. Okay, in the next example, x squared plus 10x. The coefficient of x squared is 1. So in our process of creating a perfect square trinomial, we take 1/2 of the coefficient of x. 1/2 times 10 is 5. Then we square that number 5. 5 squared is 25. And if we add 25 to x squared plus 10x, we will have a perfect square trinomial. So x squared plus 10x plus 25 is a perfect square trinomial. It's equal to a binomial squared. So what binomial is it? Since the trinomial has 1x squared, the binomial has to have x. And the number that follows x in the binomial is the same number we got when we took 1/2 of 10, which is positive 5. So we write plus 5. X plus 5 quantity squared is equal to x squared plus 10x plus 25. And the next example, x squared minus 24x. The coefficient of x squared is 1. So to create a perfect square trinomial, we take 1/2 of the coefficient of x. So 1/2 of negative 24 is negative 12. Then we square that number, negative 12. Negative 12 squared is positive 144. And then to create the perfect square trinomial from x squared minus 24x, we add 144. And then in factored form, the perfect square trinomial is equal to a binomial squared. Since the trinomial has 1x squared, the binomial has to have x. And the number that follows x inside the parentheses is the same number we got when we took 1/2 of negative 24. That number is negative 12, so inside the parentheses, it's x minus 12, quantity squared. Okay, we're going to use this process of creating perfect square trinomials to solve quadratic equations. So this method is called solving quadratic equations by completing the square. In the previous examples, we weren't solving equations, we were just creating perfect square trinomials. So now we're going to solve equations by completing the square. So on this one, x squared plus 10x minus 9 equals 0. Step 1 is add 9 to both sides, so we get x squared plus 10x equals 9. Then check to see what the coefficient of x squared is. Since the coefficient of x squared is 1, we can proceed to create a perfect square trinomial on the left-hand side. But since we're solving an equation in algebra and arithmetic, whatever you do to one side of the equation, you must do to the other side as well. Okay, so since the coefficient of x squared is 1, we take 1/2 of the coefficient of x. 1/2 times 10 is 5. And then when we square 5, we get 25. So in the next step, in solving this equation, we're going to add 25 to both sides of the equation. So we get x squared plus 10x plus 25 on the left-hand side, and 9 plus 25 on the right-hand side. The left-hand side is a perfect square trinomial, x squared plus 10x plus 25. It's equal to the binomial x plus 5 squared. And the right-hand side is equal to 34. And now we are solving an equation that we learned how to solve in section 9.1. Now we're going to apply the square root property. That was the topic in section 9.1. So apply the square root property, or apply the square root method. Okay, so since we have the binomial x plus 5 squared equals 34, we write x plus 5 equals positive and negative square root of 34. The square root of 34 cannot be simplified any further, so we just have one step left. Subtract 5 from both sides. And our two solutions are x equals negative 5 plus and minus the square root of 34. Okay, the next example, solve this equation by completing the square. This is a quadratic equation in standard form. So step 1, add 22 to both sides. So we get y squared minus 8y equals 22. The coefficient of y squared is 1. So we proceed to the next step. We take 1/2 of the coefficient of y. So 1/2 of negative 8 is negative 4. Then we square the number negative 4. The number negative 4 squared is positive 16. And then we're going to add 16 to both sides of the equation. So now we have y squared minus 8y plus 16. equals 22 plus 16. The left-hand side is a perfect square trinomial. That means it's equal to a binomial squared. So the binomial y minus 4 squared equals 38. Then we apply the square root method. On the left-hand side, we have y minus 4, and on the right-hand side, positive and negative square root of 38. The square root of 38 cannot be simplified any further. So there's just one step left, add 4 to both sides. And the two solutions are y equals 4 plus and minus the square root of 38. In the next example, there's a little bit more going on this one. So this one we're going to solve by completing the square. Negative 3x squared plus 36x equals 33. The constant is already on one side, but notice this time the coefficient of x squared is negative 3. So before we create a perfect square trinomial, we are going to divide every term on both sides by negative 3. Okay, so divide both sides by negative 3. This is something we haven't done yet, so I'll just make a note. The very first thing to do here is divide both sides by negative 3. Okay, when we divide both sides by negative 3, we get x to the second minus 12x. And on the right-hand side, 33 divided by negative 3 is negative 11. Okay, now that the coefficient of x squared is 1, we're going to create a perfect square trinomial. Okay, so now that the coefficient of x squared is 1, we take 1/2 of the coefficient of x, so 1/2 of negative 12 is negative 6. And then when we square negative 6, we get positive 36. And now we're going to add 36 to both sides of the equation above. And we'll write x squared minus 12x plus 36 equals negative 11 plus 36. The left-hand side, x squared minus 12x plus 36, is a perfect square trinomial. That was what we're trying to get. So when we factor x squared minus 12x plus 36, we get x minus 6 quantity squared. And on the right-hand side, negative 11 plus 36 is positive 25. And now we apply the square root method, or the square root property. Since x minus 6 quantity squared is 25, we get x minus 6 equals positive and negative square root of 25. In the next step, we'll add 6 to both sides and also simplify the square root of 25. So we get x equals 6 plus and minus 5. But we can simplify further, so we want to list the two solutions separately. One solution is x equals 6 minus 5, or x equals 1. And the other solution is x equals 6 plus 5, or 11. All right, so make sure you pay attention to what happened in this example. The coefficient of x squared didn't start out to be 1. So we had to divide every term on both sides by -3 so that the coefficient of x squared is 1 after that. Then we can complete the square and solve by using the square root property. And the next example, solve by completing the square. This time we have y squared minus 5y minus 3 equals 0. So first, let's add 3 to both sides. So we get y squared minus 5y equals 3. The coefficient of y squared is 1. If the coefficient of y squared would have been something different than 1, we would have divided every term on both sides by whatever that number would have been. But since the coefficient of y squared is 1, we go to the next step, and we take 1/2 of the coefficient of y. 1/2 of -5 is -5/2. Then we're going to square -5/2. -5/2 times -5/2 is positive 25/4. This is the number we're going to add to both sides of the equation above. So we'll get y squared minus 5y plus 25/4 equals 3 plus 25/4 on the right-hand side. Okay, so in algebra and arithmetic, whatever you do to one side of the equation, you must do to the other side of the equation. The left-hand side is a perfect square trinomial. So we can write it as a binomial squared. On the right-hand side, we want a common denominator. So the least common denominator is 4. So 3/1 plus 25/4 is 12/4 plus 25/4. And that simplifies to 37/4. Okay, but what binomial do we square? Well, the perfect square trinomial is y squared minus 5y plus 25/4. Since the trinomial has y squared, the binomial has to have y. And then how do we know what number follows y? Well, the number that follows y for the binomial is the same number we got when we took 1/2 of -5. That number is -5/2, so that means y minus 5/2 squared equals 37/4. You can always verify if you're ever in doubt about your factorization. You can always verify by multiplying. Okay, but now that we have y minus 5/2 quantity squared equals 37/4, now we can apply the square root property. And we'll get y minus 5/2 equals positive and negative square root of the fraction 37/4. In the next step, we'll do a couple of things. We'll add 5/2 to both sides and also simplify the square root of 37/4. And we'll get y equals 5/2 plus and minus the square root of 37 over the square root of 4 in the denominator, but the square root of 4 in the denominator is 2. Okay, so those are the two solutions to that equation. So in Newton, you have to list the solutions separately. So just to remind you, if we list these separately, one of the solutions is y equals 5/2 plus the square root of 37 over 2. And the other is y equals 5/2 minus the square root of 37 over 2. Okay, let's look at the next page. Okay, on the next page, same rules. Solve the equations by completing the square. Yeah, there was a question, since we took the square root out of 4 of 37/4, wouldn't we exclude it from the square root? That's what we did. We have the square root of 37 over, instead of the square root of 4, we have 2. All right, next page, same process. Solve by completing the square. 5x squared plus 15x minus 50 is 0. So first, add 50 to both sides. So we get 5x squared plus 15x equals 50. Since the coefficient of x squared is 5, we divide every term on both sides by 5. Divide every term on both sides by 5, we get x squared plus 3x equals 10. Now that the coefficient of x squared is 1, we can create a perfect square trinomial. So now that the coefficient of x squared is 1, we take 1/2 of the coefficient of x. 1/2 of 3 is 3/2. Then we square that number 3/2 to get 9/4. And 9/4 is added to both sides of the equation. And that gives us x squared plus 3x plus 9/4 equals 10 plus 9/4. The left-hand side is a perfect square trinomial. So that means it's equal to a binomial squared. And on the right-hand side, 10 over 1 plus 9 over 4 is 40 over 4 plus 9 over 4, which is 49/4. And what binomial squared equals the perfect square trinomial, x squared plus 3x plus 9/4? Since the trinomial has x squared, the binomial has x. And the number that follows x in the binomial is the same number that we got when we took 1/2 of 3. That number is positive 3/2, so we write x plus 3/2 quantity squared equals 49/4. Now we apply the square root property. So I'll write that down here. Apply the square root property, we get x plus 3/2 equals positive and negative square root of 49/4. In the next step, we'll subtract 3/2 from both sides, and then the square root of 49/4 simplifies. So we'll get x equals negative 3/2 plus and minus 7/2, because the square root of 49 is 7 and the square root of 4 is 2. We can simplify further, so we need to write the solutions separately. One solution is x equals negative 3/2 minus 7/2, which is negative 10/2. Negative 10/2 simplifies to negative 5. And the other solution, x equals negative 3/2 plus 7/2, is 4/2, which is positive 2. So the solutions, I'll write those up here. X equals negative 5 and x equals positive 2 are the solutions. All right, the next example, solve the quadratic equation by completing the square. So first, add 32 to both sides. So we get 2y to the second minus 10y equals 32. And since the coefficient of y squared is 2, now we want to divide every term on both sides by 2. And we get y squared minus 5y equals 16. The next step is the completing the square step. So y squared minus 5y plus 1/2 of negative 5 squared. 1/2 of negative 5 is negative 5/2, and when you square negative 5/2, you get 25/4. So we're adding 25/4 to both sides. The left-hand side is a perfect square trinomial. So y squared minus 5y plus 25/4 is equal to the binomial y minus 5/2 squared. And the right-hand side, 16 plus 25/4 is equal to 89/4. 16 is the same as 64 over 4. Sorry, 16 is the same as 64 over 4, and 64 over 4 plus 25 over 4 is 89/4. Now we can apply the square root property, and we get y minus 5/2 equals positive and negative square root of 89/4. And then y equals 5/2. We add 5/2 to both sides. Y equals 5/2 plus and minus the square root of 89 in the numerator, and the denominator, the square root of 4, is 2. The square root of 89 cannot be simplified any further. So those are the two solutions. Okay, the next example. Negative 4x squared minus 20x equals negative 4. The constant is already on one side, so we can begin by dividing every term on both sides by negative 4. And when we do that, we get x squared plus 5x equals 1. Now that the coefficient of x squared is 1, we can complete the square. We're going to take 1/2 of 5, which is 5/2. Then we square 5/2 to get 25/4. And then we add 25/4 to both sides of this equation to get x squared plus 5x plus 25/4 equals 1 plus 25/4. And note that 1 plus 25/4 is 29/4. So now we have a perfect square trinomial. It's equal to the binomial x plus 5/2 squared equals 29/4. And then apply the square root property. We get x plus 5/2 equals positive and negative square root of 29/4. And then lastly, subtract 5/2 from both sides. We get x equals negative 5/2 plus and minus the square root of 29/2, because the square root of 4 in the denominator becomes 2. Okay, we're out of time. Go ahead and sign in for attendance.
Making sense?
Yes.
I actually thought this was going to be harder than it. Like when I first looked at it, I was like, "Oh, this is going to be rough," but it's not too bad at all.
Yeah, the explanations that do, I don't know if you read those, but those are pretty good.
Yeah, I started using them, and then I wrote down a couple of them just to have them like to look at if I needed them, and then I just started going. Yeah, it all started to click. So
Yeah, just have to keep hammering away at the egg, and eventually it'll break.
yeah. Have a good day.
2.